Welcome to clickmyproject.com. This project will lead us to QoS analysis for web service compositions with complex structures. Let us see the abstract of our project. Quality of service is a major concern in the design and management of a composite service. In this paper, a semantic approach is proposed to calculate QoS for composite services with complex structures. In particular, QoS solutions are provided for unstructured conditional and loop patterns. We also show how QoS-based service selection can be conducted based on the proposed QoS calculation. Let us see the flow of our process. We take BPL process as an input. In BPL process, we are identifying the number of web services. After web service identification, we are processing process identification. In process identification, we are considering three attributes. Number 1, sequence. Number 2, conditions. And number 3, request. These operations will define the overall operations processed in this BPL process, and the links to the other files is also defined here. After process identification, we are doing pattern identification. This pattern identification is processed using WSTL file which is related to this BPL process. In WSTL file, we are considering two attributes, number 1 operation and number 2 messages. After this pattern identification, we are computing the processing attributes, the time evaluation, time computation, memory computation and probability computation. After these processing computations, we are evaluating the overall quality of service for the given BPL process and WSTL file. Open the project in NetBeans. In source packages, under QoS package, run service identification.java. Select the BPL process. View the process. Click Identify Service. Click on Services. Here we can see the list of services available in the selected BPL process. The application name here is ATM Frontend. So the list of services available here is total number of services 3 and the list of services are ATM ticket in account. Click Process Description. Click on Sequence. So here we can see the list of sequences. The sequence defines the number of processes should be processed sequentially. Then here we can see the total number of receive. How many processes we are receiving from this BPL file. It is accept connection. And the partner link here is ATM and the operation is connect. After connecting only, we can do any process in ATM. This is what the list of the receiving operation. And here we can see the total number of invoke. How many operations we are invoking from this BPL process is, the total number is 6 and the list of operations are here. So we can do create ticket, check access, query balance, update balance, again query balance, customer and update balance. It's an account operation. Click on pattern description. Here we are going to select the WSTL file for the respective BPL process. Here we can view the WSTL file. Click on service pattern. Click on pattern description. So here we are having what are the list of port types in the WCL file. It is 3. One is ticket issuer, an account system, and front end. Here we can see the list of operations in the WCL file. It is total number of operations is 12, and these are the list of operations. After invoking the BPL process, this WCL process will be invoked and these operations will be processed. It is converted into tree now. Click on BPL tree. So here we can see the number of processes, sequences and receive operations of the BPL process in the form of tree. It is in hierarchical tree, so we can see here. Click on WCL tree. So it's in a tree structure for the WCL process. The operations and sequences. It is the port type. Three ports are here, and these are the operations in the WCL file. Click on service probability. Click on memory computation. It will compute the total processing memory needed to process this operations of ATM. That is, to process the BPL file and WCL file to get any operations. So the service needed this much bytes for execution. Click OK. Click on time computation. The time is computed and the time is 278 milliseconds. Click on probability computation. Here we are having 3 services. So for each of the services we are calculating the probability, and the total probability of all services is 16. So click on QoS. So here we are showing our efficiency, service efficiency. It is the service memory. It takes an MB, so it is 10 MB. The overall processing memory needed to execute this BPL process and WCL file is this memory in MB, and it is the service time in milliseconds. So it takes this much time, this much milliseconds, and service probability in percentage. It takes this much probability. And click on QoS efficiency. So here an existing or system or proposed system is efficient than the existing system. We show it using the probability. We are combining 3 parameters for QoS evaluation. One is time, another one is processing memory, and one more thing is probability. So by combining these 3 parameters, we showed that our proposed formulation is efficient than the existing one. Thanks for watching.